Hello everyone, my name is Utkarsh and I welcome everyone to Ortelius Visionary 2023. In the next 10 minutes, I'm going to talk about one of the features that we are planning to integrate in Ortelius. Um, like this presentation will be specifically around how we can classify our workflow using machine learning algorithms, because this is one of the initial steps that we have already started working on, and this needs to be completed as a part of that feature. So let's deep dive into it. As I said, this problem statement is pretty simple. We want to optimize the workflow for any given repository. So Um, today, what happens if you integrate your repository with Open Source Security Foundation scorecard? Your repository will get a score ranging from 0 to 10, 10 being the best and 0 being the worst. And let's say if you have defined your workflow and that workflow has got a score of less than 5, there is a huge opportunity to optimize your pipeline, right? You can optimize your pipeline to strengthen your security. Um, Here I have divided this problem into 3 parts. So basically, to achieve this solution, what we'll do, we'll divide this problem statement into 3 parts. First, we'll classify if this particular workflow is good or bad. Secondly, once we have classified if our workflow is good or bad, we are going to generate suggestions for the repositories, or even we can generate the code itself using generative AI. The next step would be, to automate the code commits in the similar way as it is done today by Dependabot. So we also have to do that. This is the high level design what we are going to do. Machine learning. Okay, so I'll talk about the data in a bit, but before that, let me walk you through it on a high level what we are going to do, how our flow will be. So first of all, we are going to train our model, machine learning model. The data will be using the data that is already there and provided by Open Source Security Foundation. So Open Source Security Foundation already have a data for more than 1 lakh repository. Sorry, 1 million repository, and we can use that data. We can leverage that data to train our model. We have a many other attributes that we can leverage when we will be moving to the second step, which would be to generate suggestions or generate the code itself. After we have trained and tested our model, we are going to create a package so that it can be consumed by any of these pipelines providers. And let's say if your if your package has predicted the workflow is good, so you can go ahead and execute your workflow. But in case if your prediction is bad for your workflow, you can add your own conciliation steps. You can even stop your build, or you can add another things like notification or something. So yeah, so this is the data that I was talking about. So if you see here, I have just searched for, this is a big data query, by the way. And here I'm searching for the repository name, and I'm just using the average for a score so that I can group by, because it has like all those snapshot for a repository from like which point to which point, it has propagated. So here I'm just interested to see like how many repository it has. So here if you see, the result has more than 1 million repository, more than records. That means these many repository data it already has. And individual repository, the data for the individual repository is also pretty huge. So let me show you. If you see here, I'm using the API that are provided by Open Source Security Foundation. I have Here I'm trying to fetch the result for Ortelius project. So here if you see, this is the actual data that they are storing at their end. This is the overall score, and here you have like a lot many other checks, like what all checks that are already been there, and what all scores that are provided by Open Source Security Foundation corresponding to individual checks. So we are going to use all of these attributes when we are modeling our machine learning model, so that um, we can add consideration for these attributes as well. Going back to my presentation, this is the data that we are going to use this. Talking about the challenges, the first challenge would be, as I showed you, the data is in a form of JSON, right? So we had to extract um, the necessary attributes which will be useful in training our model. And the second step would be, removing those extra attributes that might not be helpful in training our models. So there will be a lot of effort would be required to change the format from JSON to tabular form, so that we can use the tabular form to, train our models. The next challenge would be feature extraction, where again we have to focus on different feature extraction techniques, so that we can like test out our training data, and like how many features minimum are required um, for the data that we have. So basically here, what we want to avoid is underfitting and overfitting. So what happens in case of overfitting, if you are training a data with some features, it will work well with the repositories that you have considered, but let's say if there are any new repositories been added or new workflows, so in that case it becomes very random. The prediction becomes very random. So we just want to avoid those situations. So this was about the feature extraction. The next challenge would be there for what happens right now, we are pulling up the data from Open Source Security Foundation and training our own model. But we have to find a solution wherein we can leverage the data that is already being there um, at the Open Source Security Foundation side, and so that the incremental data that are getting stored at the Open Source Security Foundation side, we can leverage those incremental data and refine our model. So I think that will also, if we do so, that will also avoid any other things, like let's say if they have upgraded or updated the benchmarking criteria for adding scores. So we don't have to we don't have to train our model from beginning itself, and we can easily incorporate all those changes in our model. Okay, so before going there, I'll quickly show you one small sentiment analysis code that I've done for different data sets. So here, like almost most of the things will be same. It just we have to extract our data into a representable form. So once that is done, we can use the same sort of code to train our model. Let me open this. Okay, in the meanwhile, I'll show you two of the features. Okay, here it opened. So here, if you see, the third column is basically the tweet, and second column is the label. So for every tweet, since this is a training data, so we have already classified like which all tweets are positive and which all tweets are negative. in the similar way, we also know like which all repository have which all score, and based on like I think I'm going to use the some threshold, let's say 3 or 4, and what I'm going to say for all this repository which has the overall score less than 3 or 4, they will be classified as bad workflow, or like need improvement type of workflow. And so yeah, that is how I'm going to create the table for all those data. um, that data, this type of data will be used to train our model. Yeah, so let me show you the main part. Yeah, so this is the file path that I've defined for my data set. And later, I'm just doing a pre-processing and a split. So pre-processing will involve cleaning up the data, doing a feature extraction using n-grams approach. We can use unigram, bigrams, any of this approach. And yeah, we have to do some hit on trial to see like which all feature extraction approach are working good. So all those things will be happen here. And later, once we have done, we can do a validation. So basically what happens in validation step, so I'm using a tenfold validation. That means whatever data that you have, that will be split into 10 parts, and based on those 10 parts we can define like a 20/80 ratio. So it will train your model with a 20% data, and it will again test your data with the remaining 20%. And this is the overall precision, recall, F1, and accuracy. What I wanted to show next here is the confusion matrix. So after we have modeled our model to classify our workflow as a good or bad, we'll get a confusion matrix like this, something like this. So which has like the rows are the true values. So these are the true values of the labels, and these are the predicted ones. So basically, we want to reduce the count for positive, negative, and negative, positive. So basically, this is the false negative, and this is the true positive. So we want to reduce the count for these. The lowest the number on in these quadrants, the better is the model. And individual values for these labels can be seen by the classification report. So again, it has a lot of inference added to it. Using a number, we can inference a lot of information, which I would be interested to see when I train a model for a workflow. Here we can see recall for positive is more than negative. That means this model is intended towards predicting more of like positive labels. So it's like even if you want to take a chance, so in that chance we have added more weight to doing a prediction to a positive rather than doing. So that was it about this presentation. I still need to work on it to finalize everything. But yeah, this is the approach that I'm going to take. If you want to explore more about Ortelius, this is the GitHub URL for Ortelius. You can even visit ortelius.io. That has like all sort of information that you're looking for. You can also follow Ortelius. The handle for Ortelius on LinkedIn is Ortelius-open-source. And on Twitter, you can follow Ortelius with the handle Ortelius OS. You can also follow me. My handle on Twitter and LinkedIn is Code with Utkarsh. Yeah, that's it for today. I hope you enjoyed this. Thanks everyone for listening.